This is a big CNC machine. In truth, when we cobbled it together, I didn't know what we were going to be using it for. It defies the first law of CNC building, which is to decide what you'll be cutting and then calculate and design your machine around that. When you're into upcycling and using reclaimed materials, a versatile tool is a powerful tool. This video is about exploring that power. A while ago I sent these big planer knives from the thicknesser away to be sharpened, and they came back looking a lot rougher. Admittedly they are sharp, but they're just so much rougher than they were before. So anyway, high-speed steel, this grinding disc, the CNC machine. Oh, and one other thing, I was given this magnetic chuck. It doesn't work at the moment, it doesn't switch on or off, but it'd be quite cool to be able to use that somehow in the whole process. Let's see what we come up with, yeah? Judging by the other side, there was some kind of tapped hole there at some point, but it's just full of congealed something. I don't know what that stuff is. Now we've got some cleaned up threads on the edge of the mag vise, let's make some brackets to hold the whole thing at a nice angle for planer blade sharpening. Here's what we've got from that scrap. The makers of this thing sure didn't want people going inside, as well as the obligatory "the world will collapse in if you open it up" warnings. There was also epoxy covering some of the screw heads, and one screw that was just very well seized in. Once the screws are out, there's the magnetic force holding it together, but also some very tightly fitting metal dowel pins. For some reason I was expecting more magical pixies inside that make this work. Simply a block of magnets spaced out with not very magnetic material, and that whole block is shifted side to side to line up or not with magnetic material in the top and bottom plate. It's really super simple if you pretend we understand why magnetism works. The reason this chuck wasn't doing anything was simply that this middle block was seized in place. It's designed to kind of sit in a bath of oil, rather than sitting on a stiff paste of rusty sludge. After cleaning and flattening down all the mating surfaces, verifying it actually works, we can put it back together with some liquid gasket type material that you get for car sumps. And there's a little oil plug where you can fill the whole thing. Now all we need to do is flatten the surface. I know what you're thinking. Flowering elbow, why aren't you using a surfacing bit to make that flat spot on the MDF? I'm glad you asked. Let me tell you a story about slate. This little would-be house sign is a tester, and it gave us confidence that the machine could actually cut slate. Problem is, if the surface is this uneven, turns out engravings look really sucky, leaving you to do all kinds of barbaric chiseling and remedial God knows what. For the next test, the obvious thing to try was flattening the slate on the machine the way you would a wooden slab or the spoil board, and in fact that's the same bit I'm using here. It's nothing special, a carbide surfacing bit, and in fact it was a bit blunt before we started. Got quite the pushing. Went past the carbide bits and into the backing behind. If you don't mind the unintentional carbide regrind and the slight undulations, that actually worked quite well, considering at least they were proof of concept for something way more intimidating. Back when we were in fully fledged lockdown here, around about the time when our humble leaders were taking a well-deserved party as it turns out, like too many other people, Sam's dad passed away in hospital, where we were forbidden to visit. So yeah, if you have any idea of the price of a memorial stone, you'll probably guess what we're up to here.
Oh, good lord.
After explaining what we were up to and selecting this enormously heavy chunk of slate at the slate yard, the guys there kindly offered to surface it with their massive diamond grinder wheel thing. And honestly, I wasn't going to be doing any more flattening on the CNC machine. Not of stone, anyway. The stone is a shade over 3 inches, meaning I had to get creative to get the whole way through. Luckily, with a lot of patience, it's soft enough that it's possible. After agonising over fonts for a good while, knowing full well they'd look a bit different engraved on a surface, we tested some out on the offcuts. We liked them well enough that halfway through we decided to repurpose them as bookends for a slightly morbid, bizarre wedding present for Sam's sister. It's going to be the heaviest thing that's going to have gone on here. Almost just the right height. I'm a bit nervous about bodging this up while Sam's away. Yes, okay. Okay. It's a bit shoddy on the back side compared to the front now, so we'll have to give it a good sand down. Okay. Put it back gently. It's not laying exactly flat, so we'll have to now make sure it's parallel with the actual spindle. Well, that is way more all over the place than I'd hoped. We'll just have to zero in each either letter or word. So now I'm having a moment of, oh shit, is this really going to work? And I might just try it on some wood, just a layer above first to see what happens. Okay, well, as this is supposed to be about the CNC machine, not my headstone related anxiety, here's something to note. The way it clamps in here, it's just some opposing wedges used against the concrete side rails. I've used this method a few times now on quite big things, especially it works well. It's interesting because despite the obvious mechanical advantage of having raised up side rails versus tall moving gantry side plates, is that they get in the way and make it harder to access workpieces and that kind of thing. And there's a good deal of truth in that, but the raised rails, as well as keeping the chips further away, can actually be handy for clamping things up. Having next to no experience of working slate, I was well pleased with how it sands. It comes up really nice. There was some chip out from where we cut these triangles off, and after looking at it, Sam and me both kind of liked it, so we ended up making that a sort of feature of the top bevel. So yeah, hopefully that explains why we were using that inappropriate cutter to make this flat spot for the mag chuck. Now, before we attempt to grind it in, because I don't want to annihilate the CNC machine with horrible grinding dust, we need to go on one of those highly rewarding but slightly inconvenient side quests to make some kind of dust shield that's big enough to fit the grinding wheel in. Another one down. Just as a quick tip, if you're lacking material, then check out your local art school skips. The dross and flotsam of creativity turns out to be quite rich in raw materials. The idea of reusing old crap like this is wonderful. The implementation sometimes is just a bit hateful. We might be on a complete bungling fool's errand, but we're going to take this rectangular section and try and taper it down to a circular section. I've wasted an obscene amount of time already on Fusion 360 learning how to model that. Without getting into the weeds too much, this is the part with the piece we've already made. If we look at just the transition, it's designed to be a sheet metal part as far as Fusion 360 is concerned. It has a seam, so it makes sense as a sheet metal part. And if we unfold it and look at the flat pattern, there's a problem here that you can see when you go to the side, in that I just couldn't get it to fold flat. I don't know why, and I never got to the bottom of it. Sometimes you just got to live with these mysteries. I think it'd be really cool to see through it, so we're going to try and cut it out of the same material. Considering how difficult it was to bend this to shape, we'll see how it goes. These will be the folding guides. I think I'll need to have even a remote hope of making this work. These single flute bits are turning out to be quite fragile. They were very cheap for a pack of 10, but this one broke and I've no idea how. It was not even in the machine. Okay, there is our transition piece. Oh. Schoolboy error. Well, it's not exactly how I envisaged it, but I think this is as good as it's going to get, so I'll put some super glue on, see if we can't hold it in this position here. We're using thick viscosity. Let's try out the dust shoe. By the time it was ready and some other hijacking jobs were done, it was time to re-level this patch of MDF spoil board before we could grind in the mag vise anyway. Still, it gives me a chance to see the swirly suck-uppy magic in action, and it looks quite promising in terms of the dust extraction. So just adjusting the height, put that in, looks okay. Now the mag chuck's in place, but unfortunately the dowel pins are sticking up proud of the surface now, so before we can put anything on it, although it's still very flat, we just need to clean up the surface, or grind it in as they say. This really should be quite a test for the spindle. Not only are we going at only 3,500 RPM, which is crazy slow for a 24,000 RPM spindle, it's got to maintain that for roughly about 45 minutes according to the machining time. Let's see how warm it gets or whether it can manage at all. Okay, you can see that there, that's what we're aiming for. Okay, I think we're off to the races. What becomes immediately evident is the slight tram of the spindle, which sends the sparks in a particular direction. The dust shoe is connected to the shop vac via a cyclone, and it is pretty cool to be able to see into the dust shoe to see that sucking up in action. Unfortunately, because the dust shoe is hanging off the side of the mag vise, the vacuum forces on the grinding dust are just way reduced. In an attempt to capture more of that, you can see I've rigged up a bit of MDF here just at the same level. Now for the little protruding dowel pins, I thought this was actually working not too bad. Then we started getting to the main body of the material. things went downhill from there. I tried various different things, using little bits of coolant on the thing, different feeds and speeds, including slightly naughty ones that were overrating the grinding wheel. The more things I tried and the more I continued, the more hesitant I got, the more sparks I saw flying out uncaptured, the more grew that sinking feeling that I was making a terrible mistake. The poor spindle grinding to a halt and moaning in complaint each time it hit a high spot. It was not a reassuring experience. So how did all that go? It went absolutely awfully, that's how it went. Surface grinding on that edge of a grinding disc just doesn't make sense. Too much of it is contacting the workpiece, and I really struggled with it heating up. More on that later. Because of the very slight tram on the spindle, the sparks were going in a different direction, so sparks and abrasive dust went flying all over the place, just like a Catherine's wheel. Too much of this is in contact with the chuck at once, versus if it was spinning that way, it heated up, lifted higher, and so then tried to grind more heavy. The spindle is completely not designed for this. It stayed nice and cool, and I was piddling around with this for a good few hours. So I'm actually quite impressed with the spindle, and also my own foolhardiness at trying to get it to do something so silly. This thing should be used with flood coolant. It can go dry, but I was warned it would be much better with flood coolant. That would have improved this whole thing no end, and it might have even worked. Flood coolant on an MDF spoil board doesn't go very well. I think we might have got through all the reasons why this was a complete fool's errand. Thought that was going to be quite nice. Turns out though, the magnetic field lines don't seem to extend towards the edge, so this is hardly held on at all at the top. And I can't have it down here for obvious reasons, the grinding wheel will snag. I can't have it that way around unless it extends over, so yep, okay, so we need to abandon this method. Let's carry on with the foolhardy optimism. I've got this bit of steel here that I'm going to try cutting a V-groove in so that we can sharpen the planer blades. You'll see how that may not work. I don't know what type of steel it is other than rusty, and mainly I just want to try out the CNC machine cutting some steel again. Let's see how we go. I must admit I'm quite excited. This is going to be the second time cutting steel. Hopefully it's clamped down firmly enough. I've been through chip load calculations and blah blah. That might all just go out the window when we start cutting, we'll find out. We're going to use this again just to try and keep the chips from spraying an upwards trajectory, which sends them a long way. You can see the helical entry there is quite dramatic. This is an 8mm carbide bit. After that, it's settling into a trachoidal or adaptive tool part, which I think is probably the way to go in steel to remove a good bit of material, at least on machines where you're slightly unsure of their steel cutting prowess. It's a sort of roughing out strategy, and it can then be finished off with a straight path like this. Okay, how did that go? Let's have a look, let's have a look. I think the bluish purplish hue means they got very hot, but then I think the fireworks were quite a good indication of that anyway. Finish is perfectly reasonable. A bit better than whatever it was that did that machining anyway. So I've just changed bits. We're going to need to do some modification to get this to go up a little bit further, or it's going to snag. This is going at 12,000 RPM and only 1mm depth of cut this time, so hopefully it shouldn't be overstressed. Only 400mm a minute, so this is going to take a while. Of course, if I was doing this again, now I would be using the MQL system you saw me set up in part 1 of this video. The cheap Amazon one's there, it's just so awkward I'm not using it. Okay, here we go. We've got those chips. Bottom's perfectly reasonable, feels very smooth, and that edge is ready for the chamfer. Yeah, I'd say that needs to be a bit more sleek. They seem quite either welded in there or the mag chuck's holding them in. It wasn't a great way of cutting it. It was recutting through these. I think the mag chuck was holding them down, so there's that stupid strategy. There's the chips. They do seem kind of welded together. Okay. What a blundering kerfuffle. The very root of the V-groove just got way too hot and it kind of looks like a weld seam or something. More importantly, the whole chuck has shifted, so almost a millimetre. It might explain why the very end here is just incredibly rough. The rest of it's really quite a nice finish. Surprisingly nice considering all those sparks. So now it's a question of realigning it perfectly. We're going to have to make the whole feature a little bit bigger, and I'll also make a relief cut with like a 4mm end mill or something just in the root of that V-groove, and hopefully that'll solve the problem. What I've discovered is that the bottom edge here, which I just assumed would be parallel with this fence, and they're completely not, out by about a millimetre in fact. So when I placed my bit of steel on here, it was actually a millimetre off squiff. So I guess what I'm going to try and do is just machine this piece and see if I can't get that straight. The problem is this is clearly going to be some kind of hardened bit of monster metal. Instead of squaring up the fence, I decided I might as well square up the side of the chuck that it actually mounts to. Then that'll be parallel to the base just below it. Good a finish as I've ever got on steel. You can see there's something coming out of the screw holes, the bit of grease or something in there that's put a streak line across the whole thing. But it is very smooth. I can't really get much from my fingernail. We should be able to see how accurate this piece is. That was rather good, but then we found the edge of the steel was a little bit wonky, so it wasn't sitting against the fence nicely. So let's clean that up. Right, now we have that clean, tight and bright in places. Let's clamp it down and begin our shameful remedial work. It doesn't help with rigidity in hardcore milling, but one of the cool things about having this big 8x4 bed is you can leave things set up and get on with actually useful jobs on other parts of it. With that V-groove finally done and satisfyingly accurate, I may say, it's time to try drilling some thick steel. This is a carbide stubby drill bit. I forget the exact PEC settings, but they're almost certainly not optimum. The T-slot block we're using to clamp it vertical very nearly gets clashed into with the collet nut. With the holes done, we're off to the mini mill to do the tapping. That's something even I'm not crazy enough to try on the high-speed CNC spindle. And then almost unbelievably, we're ready to try the original goal of sharpening some planer blades. It would have been nicer to have bolts that press down exactly perpendicular to the blade, but that was going to be hard to arrange. 4.2 that side, and this side we've got 3.6. In the middle we've got 3.5. Feels good. Because of how this was ground in the past, that side's about a millimetre higher than that side, which is a huge amount to grind off. I'm tempted to try. Well, for a first go milling high-speed steel, it was all very exciting and kind of went okay, I think. And it's left a little burr there. I wonder, in fact, if just getting that burr off would even constitute a sharper blade than it was just from this milling. There's one bit over here where I didn't catch that divot. Yes, I realise I should have got a smaller diameter grinding wheel by now, but mercifully this is actually working quite well. Here comes the closest we came to stalling. That has left us with a nice surface where we ground, hopefully you can see that, but the mother of all burrs on the back side that I thought I might be able to leather strop off, but not happening at all. With it simply flat on the mag chuck, removing a small burr like this actually works quite well. It's as good as it's going to get. Right then, I think what we've learned is if you want your planer blades sharper and straighter than they need to be, then build yourself a giant CNC machine, an overcomplicated mag chuck jig holding contraption. Use that with a poorly matched grinding wheel and a dust extraction that doesn't work, and there you go.